Welcome to lesson 9. We're going to start this lesson out a little differently. We're actually going to go to a site. It's called matplotlib.org, and we're going to go to the tutorials page on the site. And in the tutorials, there's a usage guide under the examples. And there's something that I think that's really important to realize when we're making graphs and charts, which is the theme of this week, is that one, we'll be using matplotlib. And matplotlib has been with the ArcGIS ecosystem for quite a long time. I believe it actually came in during the Arc map days back, oh gosh, probably like in the version 9x. So when we import matplotlib as a library, the standard import usually goes like this: import matplotlib.pyplot as plt, because we like to shorten the name of our imports to something easy to remember. And then we've seen this before, and that's import numpy as np. But the thing I really wanted to show you was the parts of a figure. So what makes up a chart? And when you're working with the chart, I thought their anatomy of a figure graph is great. So we have our legend, and we have a title. Then we have our major ticks and minor ticks. Then we have major tick label, x-axis label, a figure. We have minor tick labels, x-axis labels. We have spines. We have lines and markers and grids. And there's even more that can be customized about this, but these are just some of the features that are completely customizable with Matplotlib and other charting libraries within the Python ecosystem. And I start here because this is all the things you're going to be able to do to make these rich visualizations with your data as we go through, especially when you're looking at the final and taking information and you need to tell a story from that information, and you're going to take and you're going to use charts as one of your options as telling that story besides words and maps. So let's start with our official lesson. So here is Python visualization, and we're going to go ahead and we're going to begin. So this week we're going to talk about visualization, specifically Python packages and visualization. And this is going to be the first part of the build-up of going into the Python API and looking at basically making maps. This we're going to start by looking at data and looking at how we can represent attributable data in graphic form. So we're going to look at visualizations, and we're going to represent information, like I said before, in charts, diagrams, and pictures, etc. So common packages to do this would be things like matplotlib. We have the pandas visualizer, which is built on top of matplotlib. We have Seabourn, which is built upon matplotlib, but it makes it a little easier and has this nice human interface. There's also ggplot and plotly. And plotly is interesting because it creates interactive maps. So matplotlib, we saw before how we can create all and customize all these different parts of our plots, but it's been around a long time, and you can use it both in Python scripts and through the rich interactive Jupyter Notebook or the IPython shell. There's also other IDEs like Spider that have the ability to take and render the graphics out, and you can sort of see them right away. So it's pretty neat. So let's take a look at an example. So we saw before how we did our imports with this import matplotlib.pyplot as plt. And now we're going to take some numerical data. We have our x values, which is 1 through 5, and then we have our y values, 3 of them, and we're going to do a v-stack on our y data, and we're going to put the data on the graph. And here's our information. So we have our vertically stacked data, and then we're going to create a stack plot, and this information is going to sit behind it. That was just a quick visualization. Now we're going to show how we can do visualizations in pandas. And pandas is neat that we don't have to do that. The matplot.pyplot import off of a data frame. There's a .plot method. So we're going to create some random data. In this case, I'm just going to create random data, and I'm going to set the index to a date range. with 1,000 periods, and we're going to do we're going to make a plot with this. So we go ahead, it's going to create the random data, and see we get this time plot that you see a lot of times when you see maybe the stock market over time, a fluctuation of price of across the day or a year for a stock, things like that. Seabourns is another visualization library that's based upon the matplotlib syntax that we've seen so far, but it's a higher level interface, so it tries to um, take away some of the difficulties of matplotlib and make it a little easier, and it also has the ability for you to pre-customize how a map can look, so you don't have to start from scratch. You can have a base starting point with Seabourn. So to do import Seabourn, you do import Seabourn as SNS, and then here we also have, notice we're importing matplotlib. We're going to set a style, and this is going to be this predefined look of the graph that I was talking about before. And Seabourn comes with some pre preloaded data sets, and we're going to look at the diamonds one, and this is going to look at clarity and depth on a scatter plot. But we're also going to do something else that's kind of interesting. We're going to take their sizes, and they're going to show as well. I'm sorry. Well, we're gonna plot all the points on here, and we're going to do a differentiating color plot. So notice we go from this light blue to the to this dark blue based on the palettes that we passed in. And we also have some hue, which is allows us to do this what's called hue ordering for the clarity ranking. And you can see this that it appears in the legend as well. And then notice that the depth value also scales the size of the dot as well. So here I just increased the size from 1 to 18, and it made the dots a little more defined. And if you were to do that yourself locally with run it, you'll see that as well. Next, we're going to talk about scatter plots, and this is a way we can display XY coordinates on a Cartesian plane for two-dimensional data. So if we're just going to go ahead and we're going to import NumPy and use that to generate some random data. In this case, I'm going to generate it just using a random number. So every time I run it, the graphic will look the same. Get some random X and Y data. And then we're going to do something that's kind of interesting. So for the size, what we can do is we can scale our data based on, let's say we have this random value n, and we have it set up. We could change this to x, and I'm sorry. We could change it to a random sample, but we can have this associated, let's say, to another attribute within our data. So let's say it's population or vertical height or speed of a car or something like that, max speed. And you could have um, your points on the map scale also based on size, based on another fixed attribute by setting this S value to an array. Point plots serve the same as bar charts, but they're a little different. I don't know why they're basically a different style. So rather than a full bar, the values are estimate representation that point at a certain height on the other axis. So that's a nice fancy way of saying here's our data, but we're looking at our X is the gender, and if they survived the Titanic, and then we're going to use also toss class in there as our hue, so we know the difference of each line and bar, so the estimation bar. And here we can see that third class, and if you're male, you have a low chance of surviving versus male and first class, where you have just under 40%, but female first class, you almost guaranteed to survive the Titanic. So bar charts is another graph that shows comparison among a set of discrete categories. A lot of times when you see bar charts, they'll be representatives of counts. So one axis of the category shows categories being compared, while the other axis is going to represent your measured values. So let's say you have days of the week, and the number of times people visit, I don't know, Taco Bell or something like that. And you could have Monday would be your on your X value, and then the number of times people went into that Taco Bell, and so on and so forth. So it's a very common visual representation, and we can represent that. We can do it in Matplotlib very easily by just calling bar chart. Notice this time when we did our bar chart, we import our matplotlib.pyplot.plt, and then we create our first bar chart. But let's say we had two sets of categorical data that we wanted to do. So here's our second one, and then we add our legend. So notice we just chain these, and if I wanted a third, let's say we wanted to make a red, we could put that back in. Oh, I have to make it bigger, but we could change the colors and show that it's red and blue. So we could change this to, I don't know, using the McDonald's, and first is Taco Bell. And we could just show this information and whatever the numerical, maybe it's the visits over a 10-day period or something like that. Okay. So here's another example of how we can do bar plots. And this case, instead of just using some randomized data, we're going to use a predefined set of information that comes with Seabourn. Seabourn comes with a lot of data sets that allow you to play with it. In this case, I'm going to use tips, and we're just going to look at our bar plots and over 2 discrete times, dinner and lunch, and then the average tip that the person receives for that time. Histograms, they going to represent a graphical distribution of numerical data. The data is divided into what are called bins, and the height is going to represent the frequency. So we can do histogram in a bunch of different ways. In this example, we're going to load some data by using pandas. It's this housing data set and its medium home values. And we're going to build our bins by calling plt.histogram, where our x is our data. We're going to auto bin, so we're not going to really worry about it. Provide a color. So notice this time, instead of providing the single letter, we have hexadecimal. We can set the alpha and the width, and then we can also go ahead and set some other information. So here we're defining some grid. The axis is y, some opacity or alpha, and then we have our x label and y label for our grid, and with the title, and then we're going to go ahead and look at this information. So here we go. We have our histogram, and notice that we can see that it has a left skew distribution, except for when you get up into the really high value homes. It's pretty interesting. We can do this again by using Seabourn. So notice before we had all this other, we provided all these other features to it, but we can do the same thing in Seabourn, and notice that it takes care of a lot of the formatting for us in Seabourn. So if we look at, so what we did in one line of code, we almost copied before with the previous code that we did in multiple lines of code. So this is just a way of making life a little easier. Pie charts, I personally think they're not a great way of representing data, and they're also have sort of fallen out of favor, but a lot of people still like using them. So I'm going to talk about them. And pie charts is a classical way to show the composition of information. And a lot of times you see it broken down into percentages of things, but it's not recommended because they often are misleading. When using pie charts, especially if you're using percentages, make sure that you specifically write down the percentage of what each slice represents. So here's an example. We're going to start out, and we're just going to look at a bad pie chart. So what we have here is we're going to plot. So we do our data frame.plot and kind pie. We're going to look at the various vehicle classes, and this is a bad example. And notice that we really can't tell the difference between midsize and compact, and even auto compact, and pickup kind of look the same as well, but we're not sure. We can tell two-seater is pretty small, but we don't know how much. An SUV seems to have the biggest slice, but we don't know what all these percentages actually mean. So we can take that same exact data and let's sort of redo it and put our percentages in. And this is a slightly better bar chart. So we have our title, which we set the title as the class of vehicles, the pie chart. Um, we set some other information. So for our legend, we set the title, the location, um, and where we wanted to anchor it on our graphic. We also did some auto text and stuff to help format it a little better. But what we did that was nice is that we set our text for this information and we have our percentages on here. So here we can tell that at the various types for each color, we have the associated amount. So I can see that my mid-size is only 4.7 with 11 values representing that one. And then we have our biggest pie, which is SUV, has 62 occurrences and is 26.5%. Oftentimes when you have XY data, especially if you're working with geographical data, you can have a lot of overlap in the data. And to handle this, Seabourn has a plot called Jitter Plots that's really helpful for this use case. So we're going to go ahead and we're going to load in this information again here, this data set, the SUV, the one about the various cars with the miles per gallon. And we're going to go ahead and we're going to plot it, and we're going to use this jitter plot to avoid the overlap points. And it has this parameter called jitter, and that's sort of going to be your offset for the points. And let's take a look at it, how it looks. What we can see here is for each vertical value, everything that has the same highway value of 25 is slightly offset. And if you zoom in, instead of seeing one point, we see that there's multiple points on a horizontal distribution for that point. So it's just another way of sort of saying, okay, I have something with the value of 25, it's slightly offset, it's the same point, but not on top of each other. So you know that there's multiple values there. Heat maps are two-dimensional displays of values in a matrix. So think of them as squares mainly. They can be other shapes as well, but the values are normally colored by intensity of value. And think of some of the applications are a correlation matrix, if you're familiar with those. So let's see how we can do a heat map in Seabourn. So we're going to import Seabourn as SNS, and then we're going to load some data in. So this is flights, and we're going to pivot it, our data, and now we're ready to plot it. We're going to grab our figure and our axis, set the figure size to be 9 by 6 inches, and then we're going to use SNS.heatmap, pass in our data, annotate the boxes, format the data, set some line widths, and pass in our axis. And this is the result. And here, what you'll notice is that on this one, there is something that's probably hard for people to see is that January is actually cut off, and that's because it didn't fit within our figure size. So we can go ahead and we can fix that. And the other thing I did is on purpose is that notice that how I set the intensity. It set the intensity automatically, the default color range, but notice that the high values are light and the dark values are the low values are dark. And because we're showing number of flights, you would probably want to flip that, so low areas have lighter color and more intense areas. So one of the things we can use is, since our data was in pandas, we can go ahead and we can adjust our heat maps colors. So both matplotlib and Seaborn and pandas accept values called CMap, which is various ways of looking at color maps. And one of the default ones is cool to warm. And here, what we're doing is we're doing a background gradient for our data frame. And for each one, we're saying we want to go from cool, so our lighter value, to our high value, warm. And this is a greater representation of how the number of flights that we had before It can be represented over the years by month. So the summary and the whole point of this is that there's multiple ways to visualize data, and there's lots of libraries out there. Seabourn and Pandas are probably going to be your two go-to libraries. And then if you need to do something really customized, or you probably want to stay with Matplotlib when doing your visualization. You need to craft your visualization to meet your needs. And it's good to understand the foundational things of Matplotlib before you go forward. And rule of thumb is just like with mapping, you never want to mislead individuals with hard to read graphics because it's just not right. You want to make sure that your message is clear and concise and everyone can understand it. So thanks for listening to the lesson. From here, go and post any questions that you have to the discussion board for the week and have a good night.